For nearly 15 centuries, the tale lingered like a haunting echo, passed down through chronicles and whispers, a phantom calamity that once brought an empire to its knees. This was no ordinary sickness, but a plague so immense that it seemed to rise from the shadows and vanish just as suddenly. History remembers it as the Plague of Justinian, named after the Byzantine Emperor who ruled during its first terrible outbreak. Yet, that name barely hints at the scale of devastation it unleashed. For more than 200 years, waves of this relentless disease struck again and again, sweeping across the Byzantine Empire and far beyond. Ancient writers captured its terror vividly, describing deserted cities and lifeless streets. Still, the true cause of this catastrophe remained hidden in mystery. Now, thanks to groundbreaking science, we finally hold direct genetic evidence that reveals the invisible killer behind it. The story begins in 541 AD, in the bustling Egyptian port city of Pelusium. From distant shores, a ship arrived, its deadly passenger carried unknowingly by a flea clinging to a rat. What it carried was unlike any illness the world had seen before. The historian Procopius recounts the horrifying symptoms: fevers that burned through the body, confusion and delirium, and grotesque swellings that appeared in the armpits and groin. Death followed swiftly, often within just a few days. From Pelusium, the plague surged outward, racing along the empire's trade networks. By 542 AD, it reached Constantinople, the jewel of the empire. The devastation there was beyond imagination. Emperor Justinian himself fell ill, narrowly escaping death, but his survival brought little comfort to his people. Accounts describe tens of thousands lost in a matter of months. At the height of the outbreak, up to 5,000 souls perished in a single day. The plague did not stop there. It spread across the Mediterranean, devastating North Africa, sweeping into the Levant, and creeping into the farmlands of Western Europe. For nearly 2 centuries, it returned in deadly waves, only to vanish mysteriously around 750 AD. In its wake, it is believed to have claimed between 30 and 50 million lives, nearly half of the world's known population. Some historians argue this staggering loss of life hastened the decline of the Byzantine Empire, while others see its fall as the result of more complex forces. Yet, what remains undeniable is the shadow the Justinian plague cast across history, an ancient terror whose true identity has only now been unmasked. One fact remains beyond doubt: the Plague of Justinian carved its place in history as humanity's very first recorded pandemic. For centuries, scholars could do little more than guess at what caused this terrifying scourge. Chroniclers described symptoms that echoed those of the later Black Death, leading many to suspect Yersinia pestis, the same bacterium behind the infamous bubonic plague. But suspicion alone wasn't enough. Yes, traces of Y. pestis had been identified in skeletal remains from Western Europe, far from where the outbreak began. Yet within the Byzantine Empire itself, the very heart of the epidemic, no concrete genetic evidence had ever been recovered. The question lingered: was the Justinian plague truly the same disease? That mystery has finally been solved. In a groundbreaking study published in Genes in 2025, an international team of scientists, led by researchers at the University of South Florida, uncovered long-sought proof of the plague's origin. And their discovery came from an unexpected place: a forgotten mass grave beneath the ruins of a Roman hippodrome in Jerash, an ancient city just 200 miles from Pelusium, where the plague was first recorded. Known in antiquity as Gerasa, Jerash was once a thriving city of the Eastern Roman Empire, celebrated for its majestic temples, theaters, and grand colonnaded streets. Its hippodrome, constructed in the 2nd century AD for thrilling chariot races, stood as a proud symbol of civic life. But by the mid-6th century, its cheering crowds were gone. The great arena had fallen silent, its chambers converted into pottery workshops, until crisis transformed it into something far darker: a mass burial ground. During excavations in 1993, archaeologists unearthed a haunting scene beneath the hippodrome's chambers W2 and W3. Beneath collapsed stone seating and layers of discarded pottery, they discovered the remains of around 150 adults and 80 children hastily buried together. Shattered pottery fragments, dated to the late 6th and early 7th centuries, suggested these tragic deaths coincided with the era of the Justinian plague. To uncover the truth hidden within these bones, researchers turned to cutting-edge science. From the graves, they carefully selected 37 well-preserved molars and 2 rib bones, chosen because of their structural strength and absence of severe dental disease. These samples were then subjected to advanced testing. The first step, proteomics, a powerful technique that identifies microscopic protein fragments left behind by ancient pathogens. Using mass spectrometry, the scientists analyzed these molecular traces in search of the unmistakable fingerprints of disease. The scientists uncovered faint traces of Yersinia pestis proteins in several bone samples, an early sign pointing toward the plague bacterium. But the true breakthrough arrived when they turned to ancient DNA. In a sterile, contamination-free lab, researchers carefully extracted genetic material from the pulp of 8 teeth taken from 5 different individuals. What they discovered changed everything. Through whole genome sequencing, a technique that deciphers the bacterium's entire genetic blueprint, they identified Y. pestis DNA in all 5 people. Even more astonishing, the genetic profiles were nearly identical, with an average nucleotide identity of 0.999. In simple terms, think of the bacterium's DNA as a book written with 1,000,000 letters. The strains found in these victims were like 5 copies of the same book, each differing by just a single letter. This near-perfect match revealed that one highly virulent strain had ripped through the population, triggering a fast and catastrophic outbreak in Jerash. For historians and scientists alike, this was the long-awaited proof. Yersinia pestis had indeed been at the epicenter of the Justinian plague. For centuries, the evidence had been circumstantial, based on chilling descriptions in written records. But now, at last, biological confirmation had surfaced from the very heart of the empire. To place this discovery in context, the team performed a phylogenetic analysis, essentially constructing a family tree of the plague by comparing its DNA to both ancient and modern Y. pestis strains. Their results revealed that the Jerash strain clustered tightly with other, first pandemic lineages. Even more intriguing, it bore a striking resemblance to the Tian Shan strain, unearthed in Central Asia's Tian Mountains. This suggested a likely origin for the Justinian plague somewhere on the vast Eurasian steppes. The Jerash strain also provided crucial insights into why this pandemic was so devastating. Researchers identified several virulence factors, special genes that allow the bacterium to infect hosts and spread with deadly efficiency. One such gene, YMT, enables Y. pestis to survive inside the gut of fleas, making transmission to humans via bites not just possible, but alarmingly effective. The presence of this gene in the Jerash strain, and in later strains from the second pandemic, including the Black Death, underscored a chilling continuity of lethal design. This discovery built upon earlier findings, such as the pivotal 2013 study from Johannes Gutenberg University Mainz, further cementing the genetic links across centuries of plague. Together, the evidence paints a stark picture. The Plague of Justinian was not just a mystery of the past, but the beginning of a genetic lineage of terror that would echo through history. Earlier studies had already detected traces of Yersinia pestis in ancient DNA taken from a cemetery in Aschheim, Bavaria, more than 2,500 kilometers away from Pelusium, where the plague was first recorded. But the sheer distance left researchers uncertain. Was the outbreak in Western Europe truly the same disease that Byzantine chroniclers had described in such chilling detail as the Plague of Justinian? The 2025 Jerash study provided the missing link. Unlike the 2013 research, which had only partial genetic profiles, this investigation recovered full genome sequences. These offered a far more precise look at how the strain evolved and what made it so virulent. For the first time, the genetic fingerprints of the plague matched directly with the empire's heartland, confirming that the same deadly bacterium was responsible. But the work doesn't stop there. The research team has already set their sights on new sites of investigation, including Lazaretto Vecchio, the notorious plague island of Venice, where victims of later outbreaks were quarantined. By examining remains from such locations, scientists hope to uncover the plague's hidden pathways, revealing how this disease not only appeared suddenly, but also managed to endure across the centuries. The discovery of Yersinia pestis in the Jerash mass grave is more than just scientific proof. It is a reminder of how fragile even the greatest civilizations can be. From the bustling port of Pelusium to the glittering cities of the Byzantine Empire, the plague swept through society without mercy, reshaping the course of history. Thank you for joining us on this exploration into one of humanity's most haunting pandemics. If you found this journey through history insightful, don't forget to like, subscribe, and share your thoughts in the comments. Until we meet again, farewell.